A new Alma image has revealed extraordinary fine detail that has never been seen before in the planet-forming disk around a young star. These are the first observations that have used Alma with its antennas at almost their maximum extent. This has resulted in the sharpest picture ever made at submillimetre wavelengths. The new results are a huge step forward in the observation of how protoplanetary disks develop and how planets form. This is the ESOcast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. Alma, the Atacama Large Millimetre Submillimetre Array, is the world's most powerful telescope for observing the cold universe. It consists of 66 high-precision antennas that can be placed in different configurations. For the first time, the Alma array has now been configured with the antennas up to 15 kilometers apart. This is close to the maximum possible baseline of 16 kilometers and allows Alma to discern much finer detail than has ever been possible up to now. For Alma's first observations in this powerful new mode, researchers pointed the antennas at HL Tauri, a young star about 450 light-years away, which is the resulting image exceeds all expectations and is sharper than images routinely obtained by the NASA ESA Hubble Space Telescope. It reveals unexpected fine detail in the HL Tauri protoplanetary disk, which consists of material left over from the birth of the star. The image shows a series of concentric bright rings with enigmatic dark patches. These structures are clear signs of the presence of multiple planets as they sweep up material from the disk. HL Tauri's disk appears to be a lot more developed than would be expected from the age of the system. This suggests that the process of planet formation may be faster than previously. Young stars like HL Tauri are born in clouds of gas and fine dust, in regions which have collapsed under the effects of gravity. Dense hot cores form and eventually ignite to become young stars. These baby stars are initially cocooned in the remaining gas and dust, which eventually settles into a protoplanetary disk. Through many collisions, the dust particles will stick together, growing into clumps the size of sand grains and pebbles. And ultimately, asteroids, comets, and even planets can form in the disk. The young planets will then disrupt the disk and create rings, gaps, and holes, such as those structures now observed by Alma. The investigation of these protoplanetary disks is essential to our understanding of how Earth formed in the first stages of planet formation around HL Tauri. May show us how our own planetary system may have looked during its formation more than 4 billion years ago. By operating in its close to final configuration, Alma has demonstrated its enormous observational potential. This starts a new era in our exploration of how stars and planets form. In the spring of 2014, a team of ESO photo ambassadors embarked on a pioneering expedition to ESO's 3 observatories in Chile. Their mission was to capture a wide range of images and time-lapses of the magnificent Chilean night sky and landscape in crisp, ultra-high definition. Join our heroes in their adventures in the arid Atacama Desert as they bring our universe closer than ever before. This is the ESOcast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. Hosts some of the world's finest sites for astronomy. They offer crystal clear views and some of the darkest night skies on Earth. This is where ESO sites its world-class telescopes. To share this unspoiled view of the sky with the public, ESO arranged an ultra-high-definition expedition to each of ESO's observatories in Chile. The team was equipped with state-of-the-art tools from the world's leaders in this area of technology. The three astrophotographers, Yuri Beletsky, Christoph Malin, and Babak Tafreshi, were accompanied by ESO's video specialist Herbert Zodet. The team began their work at the Paranal Observatory, home to the Very Large Telescope. The time soon came for the team to leave Paranal and begin a 6-hour drive through the barren Chilean desert. Their next stop was Alma, the Atacama Large Millimetre Submillimetre Array. Here, high on the Chaknantor Plateau, at some 5,000 meters above sea level, Babak, Christoph and Yuri were in for the ultimate low-oxygen experience. Human operations here are limited due to the extremely high altitude, but they worked hard to deliver as many stunning shots as they could in the cold, dry, thin air. After long nights of imaging at Alma in the tough conditions of the Chaknantor Plateau, our team took a deep breath and headed south towards their final destination, La Silla, ESO's first observatory. On the outskirts of the Chilean Atacama Desert, it is here that ESO operates several telescopes, and many ESO member states also run projects at their own facilities. The team made a tour of the large site to scout for the best places for imaging during the nights ahead. Once again, they captured some visually stunning content. ESO's ultra-high-definition expedition has resulted in a wide range of content, including time-lapses, stills, and panoramas of the night sky in superb Ultra HD quality. 10 terabytes and more than 100,000 photos in total. And for Babak, Christoph, and Yuri, this trip certainly was the perfect occasion to test their skills at the best possible sites. Chilean skies did not disappoint them. With very little public Ultra HD content widely available up to now, ESO is offering all of these high-quality visuals for audiences from consumers to broadcasters for free. You can now download the first results from ESO's website. Stay tuned for much more, as the very best images will be released as ESO Pictures of the Week over the coming months. Ultra HD adds a new level to our stunning footage of the cosmos, a whole new immersive dimension.